So basically what this is saying is, if we have a polynomial with many terms, we can really understand the end behavior based on just this first leading term, okay? So what we can do is, if you really think about what's happening, as x gets really large, I'm actually going to divide everything in this, I'm actually going to factor, okay? I'm going to factor a 2x cubed out of everything here, okay? So if I factor a 2x cubed out of this whole function, even though I know 2x cubed doesn't go evenly into these, that's fine. I can still factor it out. 2x cubed divided by 2x cubed gives me 1. 5x squared divided by 2x cubed gives me 5 over 2x. Negative 7 divided by 2x cubed gives me negative 7 over 2x squared, and then plus 11 over 2x cubed. So I can factor out a 2x cubed here. And this is equivalent, because if I multiply this out, if I distribute this, I'm going to get back the original. But now let's think of x being very large, a very large number, okay? Now whether this is going to negative infinity or positive infinity, it's a really large absolute value number. Because negative infinity is technically really small, right? Because it's far left on the number line. But if we take the absolute value, we're talking about the number itself is a big number, and then maybe it has a negative side in front of it. But if we have 2x cubed, and then we plug in a really large number, 5 divided by 2 times a really large number is going to be a really small number. So let's just say it's not even going to be that large. Let's say it's 1,000. This is going to be 5 over 2,000, okay? And then if I plug in 1,000 and I square it, so 1,000 squared is actually 1,000,000. So this would be 7 over 2 million. One more, okay. And then if I cube 1,000, I get 1, 2, 3, 4, 5, 6, 7, 8, 9. I get 1 billion, okay? So this would be plus 11 over 2 billion. Now, tell me this. How much does each of these terms contribute to the overall value of this? If I'm plugging in 1,000 here and I cube it, this is 2 billion plus 5 2,000ths minus 7 2,000,000ths plus 11 2 billionths. So here I have 2 billion, and then I'm adding 0.00, like 5 over 2,000. I'm adding 0.0025 to that. Does this 0.0025 have really any effect on the 2 billion? No, it doesn't. And so the leading term is really what's determining the behavior as x gets very large. And if I had plugged negative numbers in here, it wouldn't have mattered, because then this would be 1,900,000 or 1,999,999,999.0075, which is still really close to 2 billion. So this is the function that's driving everything. All right, I'll see you in the next video, and we'll talk about how to apply this all in